trimmed off. Determinant. You already wrote down the formula for the 2 by 2 case. So for 2 by 2, we have a matrix that looks like A, B, C, D. Those can be any numbers. And the determinant, he wrote it with like the DET, that's fine. A lot of times people write it like bars, like kind of like absolute value bars on the outside. You can notate it either way. On your assignment, it'll just have the bars on the outside, and you don't need, if you have the bars, you don't have to like look that. But that is just AB minus BC. So let's see an example of that. Here's one example. If we have the matrix 1, 3, negative 4, 2, we're going to find this from 1, 3. What's that? 1. Did I write the 1 sideways? No, I didn't. That was weird. 1, 3, negative 4, 2 is the matrix that we will find the determinant of. So our determinant is just a number that's telling us how much we're scaling that 1 by 1 block. So it's 1 times 2. Hello. 1 times 2 minus 3 times negative 4. Which is 2 plus 12.
Yeah.
So you get 14. That's it.
Wow.
So the 2 by 2 case, not too bad calculation wise. 14. Okay, 3 by 3 is very exciting. Are you ready? I had to do this 2 by 2 determinants of 3 by 3 matrices. You have to do these like in a whole section of Calc 2, so I spent a lot of time teaching this. No. Heavens no.
Well,
You
you
might
have,
die
you would
before you
literally
go by
be
what you
What would be
do.
the determinant of like a 1 by 1?
10 by 10,
The number.
the number.
What did
I have to think about that. I'm not sure.
like if I had like a 4 and a 1 by 1 square with
Yeah.
When you think about it, you can't really go to the 4 by 4 because that's like
I don't know.
right, we can see.
I'm not sure.
We can
Theorize.
figure it
Okay, a 3 by 3 matrix. So if I'm trying to take the determinant of a matrix that looks like A, B, C, D, E, F, G, H, I. Has 9 things on the inside, right? 3 by 3. This is what you have to do. There are actually a lot of different ways to do this. But the first thing that I want to do in our formula, would you go ahead, we're going to checkerboard this with like A gets a plus next to it. Okay, B gets a minus, C gets a plus. And we're like checkerboard plus or minus across. So like this D is going to be a minus, and then plus, and then minus, plus, minus, plus. Yes, there are 5 pluses and 4 minuses. Okay, this is what we do. You pick your favorite row or column.
I like it.
I like ABC all of them. So I'm going to show you ABC. You can generalize it to another one if you would like. So ABC means I'm going to use the coefficients. Those become our coefficients. We get A, I get minus B. That's that minus that we wrote next to the B, and then plus C. So we have a positive A, a negative B, and a plus C because of that checkerboard thing we did.
If we went to like the test, would that really matter?
Yeah, so if we had EF, we'd have negative B plus E minus F.
I'm not.
That's important, yeah, because it'll like change all your signs. Yeah. Okay. Then each one of these is going to have a 2 by 2 matrix next to it. It's going to split it into 3 2 by 2. So what happens is we just picked off this row. So this row is basically gone. Like we're going to forget that happened. And then when I'm looking at this first one, I have the A on the outside. I'm going to like pretend that this A column doesn't exist. So my 2 by 2 matrix that's left is this. E, F, H, I. So that's right here. E, F, H, I. And you would do the 2 by 2 matrix on that. And what, the plus or minus? No. The plus or minus only is for like the first 3 that you pick out. Okay, then next to the B, we're going to pretend that the B column doesn't exist. So the 4 elements that are left are D, F, G, I. Yeah, can you figure out what that 2 by 2 determinant is going to be for the last one? D. So we pretend the C doesn't work, it's just D, E, C, H. So if we had chosen to expand on a different, if we had chosen to like expand on D, E, F instead, then my coefficients would be minus D plus E minus F, and then like my first 2 by 2 matrix, I pretend D is there, and I have like D, C, H, I. So you take whatever four is left after you cross off like that row in that column. I pretty much will always expand on ABC just because like I'm used to it. But there are some nice things. Like if you have a row or column that has a bunch of zeros in it, then all of a sudden you're multiplying things by 0 and it makes your life easier.
Yeah.
So there's that. If there are zeros, you could take a row or column that has zeros in it. Yeah. Yeah. I would actually do the determinant first and then multiply it by A. But yeah. Okay. So then you would do the determinant of each of these and multiply. So let's see like an actual example. Ready? Here we go. Here we go. Here we go. Here we go. I'm pumped. Here's our actual example. It is the matrix 6, 1, 1 across the top, starting the determinant of 6, 1, 1, 4, negative 2, 5, 2, 8, 7. Can I change it on you? Yes, so you need, if we're going to expand across 6, 1, 1, it's going to be plus, minus, plus. It has to follow this checkerboard that we started here, like the top left is plus, no matter what you say. Okay, so we're going to expand on 6, 1, 1. Okay, let me show you how to expand on 6, 1, 1. That's when I pick. So it's going to be equal to 6 times the matrix. I pretend that this column isn't here. So 6 times the matrix, negative 2, 5, 8, 7. And I should have been more specific when I said that because it's not really that matrix, it's times the determinant, but that's it. Then I'm going to go 6 minus 1, 1 times, and if I don't really even need it right, minus 1 times. The 2 by 2 determinant that's left is this 4, 5, 2, 7. The next coefficient is plus 1. Again, I didn't even go yesterday. That means there's a like treat in the teacher lounge for teachers. I didn't even go yesterday, I forgot. Okay, and then for the last one, the 2 by 2 matrix that's left, when we got rid of that row and that column is 4, negative 2, 2, 8. Whew. Okay. Now, here we go. So what I would do this part first. I would do each of these determinants first. So let's calculate these 2 by 2 determinants. So I'm going to have like 6 times whatever comes out of this, minus whatever comes out of this, plus whatever comes out of this. So I have minus 1 plus 1. So this is negative 2 times 7. That's negative 14. Minus 5 times 8. What's 5 times 8? 40. So is that negative 54? Great. For that 2 by 2. 4 times 7 is 28. Minus 5 times 2, 10. So that's 18. 4 times 8 is 32. Minus negative 2 times 2, negative 4. So 32 minus negative 4 is 36. So our final answer is, we have to figure out what 6 times negative 54 is.
324.
Negative 324.
Yeah.
Minus 18. That's 306.
300.
And then plus 36. We get to add all that. What did you say this was? Minus 324. So we have to do minus 18 plus 36. What's our final answer there? I got negative 306. Yeah. Negative 306. That's what you meant?
Yeah.
Okay.
Yeah.
Negative 306. That makes sense, yeah. Because negative 18 plus 36 is really like just plus 18. So, yeah.
You don't have to be too many. You got three.
No, you have to do 2 of those.
Yeah.
And then,
I don't know what that was. I don't know
what was it then?
what that matrix.
That negative 306. Remember, that's what you're talking about, that parallel pipette thing, right? And so it's gonna take that unit cube that sits right here, and it's gonna stretch it out, and it's gonna turn it backwards. That's why it would be negative. So it's like negative, and then it like stretches out so that the volume is 306 instead of 1.
Yeah.
Basically, that's what we're going for, maximum. Okay, do you wanna know how to do it on a calculator?
Yes.
Yes.
Yeah.
Yes,
I
please.
know. All right, here you go. Pull up your calculator. Got one of the yellow ones. If you need one, steal one off, or check the pouch on your chair, and then if there's not one there, steal one off of the desk nearby.
I don't-
If you want your neighbor. Okay, so notice there's a little button that says matrix. It's like blue, right? It's like the 4th one down, right? So in blue letters it says matrix. So you have to hit the blue button and then hit matrix. Yeah. So now we want to make one of these matrices. So I have to go over to edit. And I'm going to edit matrix A because that's the first one. So I get to put in the dimensions. So like, let's do this determinant. So it's 3 by 3. So I get to put in 3 by 3 and it'll fill in like a bunch of, like a table for you. And you can put down. And then you can just enter the numbers where they go in that table. So I'm going to put in 6 over 1. Oh, you have to enter 6, enter 1, enter 1, enter 4, enter -2. Make sure you do negative, not minus. 5, enter 2, enter 8, enter 7. And they're all there. So we went into the matrix menu. Matrix menu was the blue button, and then the button right below map. So it says matrix in blue right there. Right? And we went over to edit, and we just edited matrix A. Okay, now I need to get out of here. Yeah. I hit graph and then clear. That's like always how I get out of stuff. Probably not the best way, but I would hit graph and then clear to get out of things. So now I need to go back to the matrix thing. So I hit second matrix. And now I go over to math. So now you can see matrix A should say 3 by 3 next to it. Did you say 3 by 3 next to it? Because we just made that 3 by 3. We go over to math, and that first one is that depth determinant. So I'm gonna hit enter. And then I have to put in A, matrix A in here. So I have to go back to my matrix thing again and click on, like, it says name. So I need to click on enter A, and then it will put matrix A in there. I'll close the parentheses.
Wow.
Yeah.
Wow.
So on your homework, I asked you, there are, I think, huh? What do you mean? You got it permanent? So you need to put in the matrix name now. So go back to your matrix menu again. So you second matrix. Oh, yeah. Second matrix.
No.
And then hit enter on A. And it will put it in there. Enter. Okay, on your worksheet, which I already put up in the class. Look at me. I didn't even do what I have. I already have that for you. Okay. No, never go to math. So on your practice, the front side just has 6 2 by 2 determinants, which will take you all of like 2 seconds to do. Remember, that's just AB minus BC. And then the back side has 2 more 2 by 2, and then there are 6 3 by 3. And I asked you in the instructions to do numbers 9 and 10 by hand. So those are 3 by 3 ones. So do 2 of them by hand, and then the other 4 just do on your calculators. Please don't do those all by hand. Just do 2 of them by hand, and then and number 10 is going to be pretty nice because in that top row there are 2 zeros. So that means that 2 of your terms here are going to be multiplied by zeros. So you know what I'm saying? Just careful with your signs on those. Okay. Basically, but then you're going to multiply it by like whatever that, the one variable that is there, it'll be a coefficient on that one. Yeah, that's it. Okay. And then I was going to, while we're working on this, I was gonna put on the matrix multiplication video, so if you'd like to pay attention, you can. Okay, yesterday my fourth hour convinced me to throw the worksheet because apparently Mr. Anderson does that.
Yeah.
Okay, I'm gonna try again. What? You don't want to?
I want to.
What if you ask someone next to you nicely if they do it? I bet you would pick one up for you, wouldn't he? Like, I have to practice, so right. Like, whoop out. And then like, whoop out, like that. Yeah, like, other side. Hi? What if I like,
It's the ceiling.
I'm really scared, honestly, I'm not really scared of like hurting you guys, I'm afraid I might get super. Okay, here we go. Ready? Hey, that was pretty good. Sorry, you guys. I'll try to be more centered next time. Alright. Not gonna lie, that was pretty fun. So. What?
Yeah, you could.
Okay. Is this Grammarly?
Grammarly?
Oh my gosh, it's Grammarly.
I've never heard of Grammarly before. I've never seen this ad before. This is so new.
What a hit ad.
Yeah. Huh? Yeah. Thank you.
The 2x2.
If I had to choose just one topic that makes all the others in your alphabet, and there's too often those unrelated business in the alphabet, it would be this one. The idea of a linear transformation.
Right, so on the back side, like all of those will be 2x2. So those are like A, B minus B. Those two are the 3x3. Those 2 by hand, those by hand. Just do 2 by hand.
To start, let's just parse the term linear transformation. Transformation is essentially a fancy word for conflict. It's something that takes an input and spits out an output for each one. Specifically, in the context of linear algebra, we like to think about transformations as taking some vector and spit out another vector. So why use the word transformation instead of function if they use the same thing? Well, it's to be suggestive of a certain way to visualize this input-output relation. You see, a great way to understand functions of vectors is to use movement. If a transformation takes some input vector, some output vector, we imagine that input vector moving over to the output vector. Then to understand the transformation as a whole, we might imagine watching every possible input vector move over to its corresponding output vector. It gets really crowded to think about all of the vectors all at once, each one as an arrow. So as I mentioned last video, a nice trick is to conceptualize each vector not as an arrow, but as a single point, the point where it skips. That way, to think about the transformation moving every possible input vector to some output vector, we watch every point in space moving to some other point. In the case of transformations in 2 dimensions, to get a better feel for the whole shape of the transformation, I like to do this with all of the points on an infinite grid. I also sometimes like to keep a copy of the grid in the background, just to help keep track of where everything ends up relative to where it starts. The effect for various transformations moving around all of the points in space is, you gotta admit, beautiful. It gives the feeling of squishing and working space itself. As you can imagine, though, arbitrary transformations can look pretty complicated. But luckily, linear algebra limits itself to a special kind of transformation, ones that are easier to understand, called linear transformations. Visually speaking, a transformation is linear if it has 2 properties. All lines must remain lines without being curved, and the order of which must remain in place. For example, this right here would not be a linear transformation, since the lines get all curved. And this one right here, although it keeps the line straight, is not a linear transformation, because it moves toward it. This one here fixes the origin, and I look like it keeps the line straight, but that's just because I've only shown the horizontal and vertical line. When you see what it does to a diagonal line, it becomes clear that it's not at all, since it's in fact vertical. In general, you can think of linear transformations as keeping grid lines parallel and evenly spaced. Some linear transformations are simple things like rotation without the order. Others are a little trickier to describe with words. So how do you think you could describe these transformations numerically? If you were to say, program some animations to make a video teaching what formula do you give the computer so that if you give it the coordinates of a vector, it can give you the coordinates of where that vector